Well, here we are, topic 6.2 continued. This is slide 2. In example 2, we're asked to determine alternate forms of the double angle identity for cosine. Determine an identity for cosine 2a that contains only the cosine ratio. We know, first of all, that cosine 2a is cos squared of a minus the sine squared of a. We can replace sine squared of a with 1 minus cos squared of a from the identity that cos squared a plus sine squared a equals 1. By subtracting sine squared from both sides, you're left with cos squared a is equal to, or sine squared a is 1 minus cos squared a in our case. So the cosine of 2a is going to equal cos squared of a minus 1 minus the cosine squared of a, which simplified, cosine 2a is equal to the cos squared of a minus 1 plus cos squared of a, and finally cos of 2a is 2 times the cosine squared of a minus 1. In example 3, simplify this expression using the identities. So again, consider 1 minus cos 2x over sine x. A. What are the non-permissible values for the expression? Well, we know that the denominator, sine of 2x, cannot equal 0. So when it equals 0, the whole thing is going to be undefined. Now, the question is, when is it going to equal 0? Well, the sine of 2x is 2 times the sine of x times cosine of x. So, when sine of x is equal to 0, or when the cosine of x is equal to 0, the whole thing is going to be undefined. Now, the sine of x is going to equal 0 when x is pi times n. And cos of x is going to equal 0 when x is pi over 2 plus pi times n. So to put those together and combine them, that means that x cannot equal pi over 2 times n, where n is any integer. Next part, B. Simplify the expression to one of 3 primary trig functions. Okay, well if we start out with 1 minus cos 2x over sine of x, and I replace cos 2x with 1 minus 2 sine squared x, and I replace the sine of 2x with 2 sine x cos x, we're left with 2 sine squared x over 2 sine x cos x. Now all we have to do is cancel and simplify. 2's will cancel. The sine will cancel in the bottom with one of the signs in the top, leaving you with sine x over cosine of x, which we know is tan of x. There we go. Part C. Use technology with the domain x has to be between 0 and 2 pi to graph both of those functions. Y equals 1 minus cos 2x over sine of x, and y equals tangent of x, and compare the two graphs. See if they look the same. And notice that the graphs can verify but not prove our answer. The top graph is the graph of 1 minus cos 2x over sine x, and the bottom graph, F2, is x equals tan x, and they appear to be identical. So we have verified it.